so let's have a look at this first question then for this drill for the fourth. Before we look at the question, just review one or two of the conventions that are involved here. First of all, the convention for the angle is always that it's measured from this horizontal positive axis around anti-clockwise. Okay? This doesn't appear not relevant for this particular question, but if you're after the angle, that's how we measure it. If you see a negative angle, it means it's coming around anti-clockwise, doesn't it? Okay? But for this one, we're interested in this other convention that we use, that we can set. So if we're doing a problem where lots of forces are acting in this direction, then we might set that to be positive. And equally, if we're considering forces that are acting upwards, we might consider that to be positive. So you set your convention, and that's what I've done in this case. Right is positive, and up is positive. So now we have to resolve this thing into its vertical and horizontal components. So first of all, if I sketched on here, that would be the vertical component of the force, and this would be the horizontal component of the force, if I sketched it. So already we can see that following our convention here, the down force is going to be negative, and because the horizontal component is acting that way, that too is going to be negative. So whatever answer we come up with will be negative, and it's important to put that in. Now, we just, as we've done before, we shift this line over to here, so to form our right-angled triangle. So effectively, we've got this. I'll draw a dotted line down here and put the right angle in. There's our right-angled triangle. So it's just sine and cosine ratios. Because the angle is opposite the vertical component, it's 40 degrees. In this particular case, and that's generally the case actually, but not always, the vertical component of the force is the hypotenuse times the sine of the angle. The vertical component is given by the hypotenuse times the sine of the angle, because in this particular case, the side is opposite the angle. Sine is associated with the opposite. So putting the numbers in, the vertical component is 6 times the sine of 40 degrees, which is, would you just like to do that for me? And so minus 3.86 newtons given to me to 3 significant figures, possibly a bit over the top for accuracy, as we've only got one significant figure here, so 3.9 or even 4 newtons, okay? So vertical component, minus 3.86 newtons. Horizontal component, exactly the same idea, only this time we're after the adjacent side to the angle, so that's associated with the cosine. So the adjacent will give us the horizontal component, which is going to be, again, the hypotenuse times the cosine of the angle. We have to just remember these formulae, and that will equal 6 times the cosine of 40 degrees, which is 3.9. Not forgetting the negative again, minus 3.9 newtons to 3 significant figures. 4.5 minus 4.5 to 2 significant figures. So 6 times the cosine of 40 minus 4.6 newtons. So that's the first question. Bear in mind the conventions so that you know what it's, I know it's negative, so I know it's going left. Don't forget the sign. And an appropriate accuracy, please. Okay, so this is not an uncommon formula to use. It's to do with a trapezium, to find the area of a trapezium, where the parallel sides are A and B. And use this symbol, the arrow, is usually used to indicate that these sides are parallel. So A and B are parallel. Vertical height h, and we've talked already about possibly having to find this vertical height using Pythagoras, but that's another story, another question. Okay? Given h, this vertical height here, we've got to rearrange this formula to find b, one of the sides. We're after one of the sides, so it could just as easily have been a, exactly the same sort of idea. If I were doing this one, the first thing I'd do, just rewriting this formula, is recognise, not necessarily write, but recognise that a half of something, as we talked about before, is the same as divide it by 2. So I could just as easily write or think about this formula as being a plus b times h all over 2. Which means that you can see what you've got to do. The first thing with these formulae, if there's a denominator, something underneath, multiply through by it at least to get everything to the top. So the first thing I would do here would be multiply both sides by 2. So I'd get 2a equals a plus b times h. So that's got rid of the denominator underneath. I might be tempted now to multiply out the bracket on the right hand side, but I'm after b, and so if I multiply this out I'm going to have a term b times h, which doesn't really help. B is on its own at the moment, so don't multiply out the brackets to make it times by h. That's not necessarily going to help. What I would do now is get rid of the h by doing what? Divide, right. Divide both sides by h. Good. So 2a all divided by h equals a plus b. Don't need the bracket anymore because the h is gone. Right. Now we're after b. Remember, we could just as easily be after a, but whatever, I want to get rid of the a in this case, so what do I do? Sorry? Minus it, yes, subtract it. So b, write b on the left-hand side because that's what we're after, equals 2a over h minus a, and done. I can now find the missing side b. So to do this one, I need to remember that the area of a circle, r squared. Okay? And I also need to realise that the diameter is 2 times the radius. Twice the radius is the diameter. I'm after the diameter. So my plan is to rearrange that formula for the circle to find the radius. Once I've got the radius, double that and I'll have the diameter. So I've got to rearrange this formula to find r. So what am I going to do first of all? No, before I square root it, I'm going to get rid of the pi by dividing. Yeah, because it's multiplied, divide. Divide both sides by pi. Area divided by pi equals r squared. Now square root. So r equals the square root of a over pi. So now I can put in the numbers. So the radius is going to equal the square root of the area, which is 12.6 over pi, 2.6. So I'm going to write that, say it's 2.0 centimetres to 2 significant figures. I know it's centimetres because the area was in square centimetres. Yeah. A note on this accuracy, because it's 2.006, it's worth putting another significant figure on to say that's 2.0 rather than 2. Okay, right. So even closer to that. So we can indicate somehow that it's actually very close to 2. If I just put 2 to one significant figure, it could be anything between 1.5 and 2.5 in theory. So by putting 2.0, that's showing me that, or whoever's reading this, it's a bit more accurate than that. So now, as you say, now I've got the radius, I've got to double that. So therefore, the diameter is 2 times 2, 4 centimetres to 2 significant figures. So the diameter is around about 4 centimetres. And I'm sure you could visualise situations where you might want to calculate that. Given the area, what's the diameter? Okay, so for this one, I think it's worth remembering some formulae, like the area of a circle and things like that. You can always look formulae up, but you know, in an engineering situation, some formulae are so basic that if you have to look them up, as we talked about right at the beginning of this course, it doesn't give people confidence if you're having to look up very simple things. So you get to know some formula and think it's worth doing those. the formula for a cylinder, and by a cylinder, of course, we all think about that sort of cylinder, circular end in other words. But remember, as generalizing this, this is the idea of the prism, which has got a constant cross-sectional area, and the volume of any prism with a constant cross-sectional area is just the area of the end. So in this case, the volume is the area of the end, which is pi r squared, times the length. So the formula is pi r squared L. Right, in this question 5 here, we've got to find the voltage. The question might just as easily have been this, look, this. Find the voltage across a 650 microfarad capacitor with a charge of 1.36 millicoulombs. And in electrical principles or in an electrical type scenario, you wouldn't necessarily say here is the formula. You've got to know the formula or look it up. So that would be the question. And the way I would do this question would always be to, first of all, identify the formula that's involved. You're given it in this case, but I want to find the voltage. I know the capacitance and I know the charge. So I'm looking for a formula that involves the charge, the capacitance and the voltage, which in this particular case you've been given. And then I'll rearrange the formula for what I want, which in this case is V. So what do I do to rearrange this formula for voltage? Divide both sides by C. So the voltage is the charge divided by the capacitance. That's the first thing I would do. Then I'll look for the information I'm going to put in and write it down. What is the charge? It's 1.36 millicoulombs. But then I'll write it in the base unit, which is always what you use. Milli is 10 to the minus 3. So that's the same as 1.36 times 10 to the minus 3 coulombs. The capacitance is 650 microfarads. So again, put that in the base unit, which is micro is 10 to the minus 6. So that's 650 times 10 to the minus 6 farads. So that's the important thing, and that's what I'm trying to test in this question. So once I've got that information, then I can put those values into the formula. V equals Q, 1.36 times 10 to the minus 3 divided by 650 times 10 to the minus 6. And then I'll put that into the calculator and give the answer to an appropriate accuracy. So if you would just like to do that, gives the value of 2.09 volts to 3 significant figures.